X bar or
At least this far away from mean, or X bar.
X bar or extreme, given an HO.
Or more extreme.
Yeah, or more extreme given an HO is true.
Yeah. Okay. We left off here yesterday where I was talking about T is a new kind of distribution. So we've got normal, binomial, geometric, and now we've got T. And T is really similar to normal, and if I have a big enough sample size, T is the same as normal, eventually. But at the beginning, it's got a bigger standard deviation, so it's more spread out, and then, like we talked about, the more data you get, the more it condenses and gets like skinnier and taller. N minus 1 is the degrees of freedom. You don't have to know what that means. I can explain it if anybody wants to, like privately, but I don't want to get into it in front of the class. So let's go down to p-value here. So again, this is just like helping you know what a p-value is. So if the p-value is 0.23, it means if HO is true, there's a 23% chance that we would get a result this far away from the mean or more, basically. The problem is it's just a long freaking definition. Like, I can see you guys, as I start to say the definition at the beginning of when I'm talking, you guys are like, oh, what are you saying? And then, like, as I go, you just go like, and your eyes glaze over. And so it's almost a matter of, can you focus long enough to get out a 2-sentence definition and know what it all means? P-value is 0.001, means a 0.1% chance that the data would show what we got if HO is true. So since that's such a small chance, what we end up saying there is, well, HO's got to be wrong. So, does anybody like swim or run track in here?
Joel,
what do you swim or run track?
She runs.
Why do you laugh so hard?
What event? How long does it take? 56 seconds. So Joel says it takes him 56 seconds to run the 400. So that's like the population mean. I don't know the population standard deviation. I just know that he says on average takes, is that fair on average? Is that like you're fast? Let's say on average. You're faster, so that's your answer. Alright, so on average, 56 seconds. I don't know the population standard deviation. That's one of our things, right? Unknown population standard deviation. So I go watch Joel run once. And Joel runs in 55 seconds. So it's like right here. Or 57. Let's say we're at 57. At that point, am I going to go to him? So his HO is that U equals what? 56. So I go watch him run, it takes him 57. Am I going to be like, well, you obviously can't run at 56. It just took you 57. You're obviously a liar. I mean, that doesn't make sense, right? What is really small right there? If I go, 57 seconds. I'm not asking. What is really small at 57 seconds? The T or the p-value? T. Because we're like really close to the middle, right? The p-value would be really big, and I would not reject HO because the p-value is so large. Scratch that. Joel says 57 seconds, or 56 seconds. I go watch him run. Excuse me. It takes him 2 minutes. He's like, there's people that are done and like walking around eating lunch, and he's still going. Now, is my T value big or small? T. T is big because I'm going to be like a lot of standard deviations away from where he claimed, right? My P value would be really small. So what that p-value represents is, if he's telling the truth about 56 seconds, there is a really tiny probability that the day I went, he just happened to take 2 minutes. But what's more likely? That, or he was lying? He was lying. I'm not calling you liars. That's what a p-value is getting at. Does that make some sense? Does that help? What? Say disgusting. A p-value is disgusting.
It is really. That's why I do it in terms of like X bar,
it's almost like a logic class sometimes. Yeah.
P-values are I'll text you. Okay.
understand it
fun.
than to say what it is. Like,
Right.
yeah. All right. So do these. This was like I was going to teach you this, but we already taught it. You already know it. Do those. But I'm not gonna.
Teach us how to draw that. Mine is super simple.
That looks freaking amazing, actually.
I cannot draw it.
I've got 40 years of experience.
Mine's not as good.
What do they talk about? It's so good.
This brace and the brace.
Oh, I did the wrong.
You're on a Waldy's last page. You got an awesome definition for not awesome definition, but awesome explanation.
Thank you. Read in the top sentence with me, because that's a vocabulary people mess up. If the p-value is smaller than alpha, we're going to reject HO, and that's called statistically significant. So statistically significant means that you rejected HO. That's important. Statistically significant means we're far enough away from the mean to basically call the original person a lie. Like the 57 seconds is not statistically significant, like how far away it is from 56. But 2 minutes compared to 56 seconds, that's a statistically significant difference. At that point, I'm going to call Joel a liar. Yeah. Don't forget your con is due Tuesday. Don't forget your corrections are due Tuesday. Tuesday. Con is due Tuesday.
Like Tuesday at 11 p.m. or Monday at 11
For the con, it's due Tuesday at 11:59 p.m.
Okay.
Corrections are due Tuesday, and that's 10:45 a.m. Kenneth? Yeah, question?
I was going to ask you about grading.
That's even got an asterisk. Yeah. See, Piles noticed that? He raised his hand, he was just going to ask me if the con was graded, but then he looked at the board and put it down.
But how do you know that you was going to ask?
Because I said, what were you going to ask? So it'll end up taking just as long anyways.
And then to tell me.
I know, now we're like triple the time.
Yeah.
Your way was actually faster, it turns out. Alright, so p-value is 0.03 compared to alpha is 0.06. We reject or not reject? Would not reject. No. Jeez. Would reject. 0.01. Would not. So true, false on the bottom two. If it's statistically significant when alpha is 0.01, that means our p-value is bigger or smaller than 0.01? Smaller. Statistically significant means we reject. So if it's smaller than 0.01, is it also going to be smaller than 0.05? Yeah, so that's true. But then flipping it backwards doesn't work. This is kind of like the number one I put on the board work. So just because it's smaller than 0.05, does that automatically mean it's smaller than 0.01 also? Could be in the middle, right? 0.03, 0.04. So this one is false. So the big thing there, statistically significant means you're rejecting H naught, means the p-value is less than alpha. Alright, one-sided versus two-sided. We've gotten into this quite a bit at this point, so I'm not too worried about it, but I'm going to run through it quickly. So this is saying mu equals 70, t is 2.05, and I'm not going to worry about finding it, but if I was shading, it'd be up there. I actually didn't give you enough information. What else would you need to find the actual p-value? What would you need that I didn't give you? and well, standard deviation I don't need because that's kind of already in the T. Like, the point of standard deviation is to find T. So I think you guys all know if it's greater than, you're looking up. I don't think this one's anything goofy either. If it's less than, we're looking below. So T would equal negative 1.9. I shaded there. I feel like you guys are comfortable with those sketches. Is that true?
Yeah.
It's fine. And then the bottom one is just, like, that's what we did yesterday. So that's the not equal to. So I just want to make sure you understand a couple things about it. So if mu equals 70, T equals 2.05, you would shade this way above that, but then you would also go do the corresponding version on the other side, and you would shade this way. Does the calculator is doing, if you do the one sample T test, the calculator pops up and says, here's your T, here's your p-value, here's all the stuff. Does it add those two up for you, or do you have to double it?
It adds it for you.
It adds it for you. If you do TCDF of like 2.05, 999, what do you have to do with your answer?
Double it.
You have to double it because that'd be the same amount now.
Thanks.
Alright. Questions on anything at this point? Yeah.
What does T represent again?
How many standard deviations you are above or below the mean? It's like a z-score, but it's a t-score, so it's like the same idea. Alright. So here's what we're doing for the next couple days. The rest of today and then also Monday. Well, you have what I need from you at some point in the class on Tuesday is these two problems written out as though it were like a paper you're turning in. And I'm going to grade it as though it's a paper and give it back to you. So you have some idea of like whether you're doing this completely right or not before we get to the test. Because right now you're basically just grading your own, right? I like the long template. You're grading your own. So like, that's probably fine, but I want to make sure.
You want us to give you definitions of people.
And so, yeah, and then I also, for like the third question is, what is a p-value? So you have to answer that for me so I can make sure that you're answering it correctly. This stuff is due Tuesday, end of class. You have Tuesday to work on either this and or your comp. So I'm done for today and Tuesday. You have time. You know what you got to do. Kayla. Yeah. Turn it in. Give me a blank sheet of paper. Well, if you can use a template. You can use a template. Remember the template's not on the test, though, so the sooner you can kind of like wean yourself off of that template, the better it is. But on Tuesday, before you leave, I need 2 written out full processes, and you tell me what a p-value is.
Do they ask for like what's the definition of certain things?
Good. It's multiple choice. That'll be a multiple choice question, so it's just kind of worked into a multiple choice.
So is it like, is the p-value this, or
Could be, or it could be.
what is the p-value of question number 5? Is it like 38?
No, it'd be more like which of the following describes what a p-value tells us. What?
Yes, sir.
I'm still recording, is that what you said?
Hi, Steven.
You don't think it's entertaining?